This slide set is designed to give you an overview / review of all of the requirements that you need for the nomenclature unit of Chem 1 for this semester. Exam 2 is fast approaching. As a heads up, warning, whatever you want to call it, approximately 40% of Exam 1 will be nomenclature and remembering the naming and knowing all the rules associated with that. So this is not a small component of the exam. It's not something that will go away. The importance of nomenclature and being able to name molecules and convert names to formulas is so that as a scientist or as a member of society, you are able to communicate what you know about what you're working with within a system. Being able to communicate right and understand the nomenclature and naming will work with you in society. It will also carry on further into your career. Once we get into Unit 3, we're going to start working with reactions and other things along those lines, and you will have to be able to know, given the name of something, what the formula of that is so that you can do the necessary calculations based off of that. There are three primary types of, not primary types, there are three types of namings that we are going to focus on within this unit: ionic naming, molecular naming, and naming of acids. Ionic naming is always covered first. Ionic compounds contain a cation and an anion. Molecular compounds are what is learned next because they follow ionic naming rules with a few exceptions. And then there are two types of acids that we are going to be concerned with. And we'll talk about those last. For an ionic compound, there are two primary types that we have to be concerned with: simple ionic naming and then naming with transition metals. Transition metals add a layer of complexity because they can have different forms, and we need to know which form of that ion that we're working with. And then polyatomic ions are introduced here. You have to know those ones highlighted in yellow on the PowerPoint in Canvas, and we'll go from there. So let's start with ionic naming. For ionic naming, the first step is to name the cation that's present. The cations always go first, the anions go second. For the cations, if it is an alkali or alkali earth metal, or metal that only has one oxidation state, which are usually the alkali and the alkali earths, you just use the element name. Straightforward within there. If it is a transition metal, so that middle block on the periodic table, you have to, or a metalloid, you have to include the oxidation state of the metal within there, having the Roman numeral in parentheses for the oxidation state. You may or may not have to determine the oxidation state of the metal. That will depend on what's present within the system. To determine the oxidation state of the metal, you need to look at the anion, figure out the relative charges, and know that the charges within the molecule has to be 0, and so you'll have to kind of think and process and work with things from there. For the anion, monatomic anions are named by dropping the end of the element name and adding IDE to the end. So chlorine becomes chloride, oxygen becomes oxide, fluorine becomes fluoride. Relatively straightforward within there. If it is a polyatomic anion, which will be present within the system within what we have, those are already in their anion form and you don't have to worry about changing their names. When you're writing the name, it's a cation that goes first, the anion that goes second. It really should have two separate words within there, and then sometimes you have your oxidation state in parentheses as part of your name as well. Once you have and are able to take the formula to the name, you are also going to be required to move backwards within there, taking the name and writing the formula from that. The formula unit is just the simplest representation of the particles present within the ionic compound. The formula unit has to be charge neutral overall. This is typically where students have the most trouble. Within here, you have to know the relative charges of the species present within there and find the smallest whole number ratio of the atoms to properly write the formula that we're working with. When you are writing the formula, just as you are writing the name, the cation always goes first, the anion always goes next. And then make sure to use parentheses if needed. If you have more than one polyatomic ion specifically, that polyatomic ion needs to be in parentheses, so you have whatever repeat of that polyatomic is that is necessary within there. I do not have the polyatomic ions within the slide deck. I'm going to recommend that you go back to that PowerPoint in Canvas and look at the ones highlighted with the yellow arrow. Those are the limited ones that we need to know. There are more than that are listed on the table, and that helps you with your homework and other online stuff that you will work through throughout the course of this semester. Molecular naming is the next component that we need to talk about. Molecular naming is very similar to ionic naming. We are going to restrict ourselves to molecular naming with only two components within there. The first element is just the element name, just like you would name the cation in the ionic naming. The second element has the ending of it changed to IDE, just like we did with the anion naming as well. The one thing that changes with molecular naming relative to the ionic naming is with molecular naming, you have to explicitly tell me how many of each of the atoms that are present within the system. So shown on table 7.4 that's on the slide, if you have 3 of some atom present, you need to tell me it's tri, whatever. 6 of that atom present is hexa. You will need to know the prefixes 1 through 10 for this course. More prefixes exist than that. We are restricting ourselves to 1 through 10. The one exception to indicating the quantity of the number of atoms present is if there is only one of the first element present, then no prefix is used. The other thing that I want to indicate and explicitly state on this slide is prefixes are only used for molecular naming. In ionic naming, because the charges are implied within the molecule, no prefixes are used. So one of the things to use to differentiate ionic naming from molecular naming is molecular naming has mono, di, tri, and tetra within there. Ionic naming does not. Ionic naming sometimes will have those Roman numerals in parentheses, but prefixes do not, absolutely do not go with ionic naming in the terms of what we're looking at. Okay, once we've named our once we've taken the formula and converted to our names, same as with ionic, we're going to have to take our molecular names and convert those to formulas within what we have. This is much easier than the ionic formulas because the charges, we don't have to be concerned about the charges within what we have. Okay, the name of the molecule that you have already tells you how many atoms are present. Dihydrogen monoxide. Di means 2, hydrogens means there's 2 hydrogen, monoxide means there's 1 oxygen, so there's 2 hydrogen and 1 oxygen, H2O within there. Make sure that you are properly using the subscripts within there. And that's it for molecular. The last type of naming that we need to talk about is naming acids. Naming acids are the most confusing and most difficult component of what we're going to work with for this semester. There are 2 types of acids that we're going to concern ourselves with, binary acids and oxyacids. A binary acid is an acid that starts with H and has one other element included within that. It can have more than 1 hydrogen, but it starts with H and has one other atom within there. Binary acids are named by putting hydro before the element stem and then adding IC acid to the end. So for example, HCl becomes hydrochlorine becomes chloric acid. So hydrochloric acid for HCl, hydrobromic acid for HBr, and it continues with from there. With the oxyacids, again, because it's an acid, it has to have a hydrogen at the front. Oxyacids have a hydrogen in front and a polyatomic ion with it. This is where you need to know the names of your polyatomic ions. If the polyatomic ion ends in ATE, it becomes an IC acid. If the polyatomic ion has an ITE as it ending, it becomes OUS acid. And you'll see some of those examples of that on this PowerPoint that has the acid naming, the full acid naming rules within there. Okay, so this is a summary of what we're working with. The molecular, ionic, and acid naming within there. Covalent or molecular compounds have two nonmetals within them. There's no charges, no ions. You must use prefixes when you're naming, and you only use the mono, di, tri, etc. within the molecular naming within what we have. Within the ionic compounds, it's a metal and a nonmetal, or a metal and a polyatomic ion. You will need to be able to differentiate a molecular and ionic compound from an acid. Ionic compounds have the metal and the nonmetal. The charges need to be 0 overall within the system within the completed formula, and there are no prefixes used within the naming here. Within the acids, there's really 3, 2, 1 with a subcategory type that you have. In acids, your best way to identify those is a hydrogen will be the first atom listed within the formula. For a binary acid, it's hydrochloric acid. For oxyacids, if your root is ATE, it becomes an IC acid. If it's ITE, it becomes an OUS acid. And you can refer to the polyatomic ion chart to look at that within there. As I said at the beginning of this, your exam 2 will have approximately 40-ish points on covalent, ionic, and naming acids. You will have a table on your exam where you'll be either given a formula or the name of the molecule that you're looking at. And you'll have to give me either the formula or the name that correlates to that. In efforts to help you rationalize and identify the type of molecule that you are working with, there will be a third column on that table in which you will have to tell me whether or not you're working with an acid, an ionic compound, or a molecular compound. By identifying the category of naming that you're using, that should help aid you in understanding the rules in which you have to apply with the naming rules from there. Come find me if you have questions. Start on this work sooner than later, and make sure that you've gone through the practice problems that are posted in the lecture slides.